Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have discussed different methods of determining of molecular weight and equivalent weight. Now I am going to discuss different methods of determining atomic weight. Here first I will discuss here also actually 5 methods are there. There are 5 methods to determine atomic weight. First method is by application of relation, that is the atomic weight is equal to equivalent weight into valency. This is the first method. By application of the relation, what is the relation? Then atomic weight is equal to equivalent weight into valency. It's a very good relation between atomic weight and equivalent weight. Atomic weight is equal to equivalent weight into valency. Knowing the exact equivalent weight and approximate atomic weight, valency can be calculated, which is whole number. And knowing the exact equivalent weight and valency, exact atomic weight can be calculated. Here you require, in this relation, you require atomic weight that should be approximate. From the approximate atomic weight, you will calculate the valency, and once you will know the valency, then you can calculate the exact atomic weight if you will know the exact equivalent weight. You remember, here you require approximate atomic weight in the beginning, but you can know the exact atomic weight when by using this formula you will calculate valency. Then valency is a whole number. After knowing the valency and exact number equivalent weight, then you can calculate the exact atomic weight by using the same formula. Now second method is DeLong and Petit's method. DeLong and Petit's method. According to DeLong and Petit's law, for solid element except beryllium, boron, carbon and silicon, these are the exception. Here it will not apply. According to DeLong and Petit's law, for solid elements, atomic weight into a specific heat is equal to 6.4 approximately. Then approx atomic weight you can calculate, that is the approx atomic weight is equal to 6.4 divided by a specific heat, and this is the approx atomic weight. By this formula you will get approx atomic weight. Now exact atomic weight, how will you calculate? Then exact atomic weight is equal to equivalent weight into valency. And how will you calculate the valency? Then valency is equal to, by using the first relation, approx atomic weight divided by equivalent weight. What I discussed the relation in the beginning, by using that relation you will get the valency, and after knowing the valency, that if you multiply with equivalent weight, means equivalent weight into valency, that is equal to exact atomic weight. Then this I told you two methods. One is the relation, other is the Dulong and Petit's method. Now third method I am telling you, a specific heat or molar heat capacity method. Okay, this is a third method, a specific heat / molar heat capacity method. For gases, lambda is equal to Cp upon Cv, you remember. For gases, lambda is equal to Cp upon Cv, that is the ratio of Cp and Cv, that is called lambda. Okay, and its value is 1.66 for monoatomic. For monoatomic, Cp upon Cv value is 1.66 and 1.40 for diatomic and 1.30 for triatomic gases. You remember, this is very, very important. This ratio Cp upon Cv is equal to 1.66 for monoatomic gas, 1.40 for diatomic and 1.30 for triatomic gases. Means Cp upon Cv is equal to 1.66. That is for monoatomic gas. Cp upon Cv is equal to 1.40 for diatomic gases and Cp upon Cv is equal to 1.30 for triatomic gases. Okay, thus having known the atomicity, this is actually called 1.3, 1.66, 1.40, 1.30. This is actually Cp upon Cv, that is the lambda. Thus, having known the atomicity of the gas from the value of lambda, atomic weight of the gases of element is equal to molecular weight divided by atomicity. Means you will use here Cp upon Cv value. This is also called atomicity. Correct? Thus, having known the atomicity of the gas from the value of lambda, atomic weight of the gaseous element is equal to molecular weight divided by atomicity. You remember, this is atomic weight. Atomic weight is equal to molecular weight divided by atomicity. How will calculate the molecular weight? Then molecular weight is equal to 2 into vapor density. Molecular weight is equal to 2 into vapor density. Now fourth method, that is the volatile chloride method. Volatile chloride method. This method can be used for those elements whose chlorides are volatile, so that their vapor densities can be determined. You remember, volatile chloride method can be used for those elements whose chlorides are volatile, so that their vapor density can be determined. Then molecular weight of the chloride is equal to 2 into vapor density. Okay, this is especially for chloride. Okay, molecular weight of the chloride is equal to 2 into vapor density. If X is the valency of the element then the formula of the chloride will be MClX. You remember, if X is the valency of the element means M. Okay, element you can represent by capital M. Then the formula of its chloride will be MClX. Down X, small x you can write. This is the formula of its chloride, MClX. Just like we are writing MCl2, MCl3 like that way, X. Hence, molecular weight of chloride MClX is equal to atomic weight of M plus X into 35.5. Correct? Molecular weight of the chloride MClX is equal to atomic weight of M plus X into 35.5, or that is equal to equivalent weight of M into valency of M. X is actually valency of M, okay, plus X into 35.5. Remember, atomic weight of M plus X into 35.5, that is the molecular weight of chloride. But here atomic weight of M you can write equivalent weight into valency, that you know the relation. Atomic weight you can, if equivalent weight is given, the atomic weight you can know. Equivalent weight of M into valency of M plus X into 35.5. Okay, means in the place of atomic weight of M you can write equivalent weight of M into valency of M plus X into 35.5. Correct? Then now this you can write this, all the things, E into X, valency we are writing as a X, then E into X plus X into 35.5. X you can take a common, then in bracket you will get E plus 35.5. X into X is outside, in bracket E plus 35.5. X is common. Correct? Then now you got the molecular weight of chloride. Molecular weight of chloride you can write, that is equal to X, outside X, in bracket E plus 35.5, and this is equal to the 2 into vapor density. Formula you know, molecular weight of chloride is equal to 2 into vapor density. If vapor density is given, then this molecular weight of chloride means MClX, that is equal to X, outside X, in bracket E plus 35.5, that is equal to 2 into vapor density. Hence easily you can calculate the X. X is equal to 2 into Vd, means vapor density, divided by E plus 35.5. Okay, knowing the equivalent weight of the element, the valency X can be calculated, and then atomic weight you can calculate. Atomic weight is equal to equivalent weight into valency. Then how will you calculate X? Valency, that also I have told you, particularly for the molecular weight of chloride. Question is asked. Okay, you remember, for the molecular weight of chloride is equal to 2 into vapor density, and molecular weight of chloride is equal to valency outside, in bracket E plus 35.5. How it came already I told you. Then this X this X outside and inside bracket E plus 35.5 that is equal to 2 into vapor density. Then X is equal to 2 into vapor density divided by E plus 35.5. Then knowing the equivalent weight E of the element, the valency X can be calculated. And when both you are knowing equivalent weight or X, if you are knowing, then atomic weight also you can calculate, because atomic weight is equal to equivalent weight into valency. And one more method, fifth method, is isomorphism method. Isomorphism method. Compounds having similar molecular formula and identical crystal structure are called isomorphous. Compounds having similar molecular formula and identical crystal structures are called isomorphous. The method is based upon the fact that elements in isomorphous compounds have same valencies. Okay, this is the main things. This method is based upon the fact that elements in compounds, elements in isomorphous compounds have same valency. Example I am telling you: K2SO4, K2CrO4 and K2SeO4 selenium, K2SO4 potassium sulfate, K2CrO4 potassium chromate, and K2SeO4 selenate, potassium selenate, are isomorphous. These three are isomorphous: K2SO4, K2CrO4 and K2SeO4, all are similar, and then these are isomorphous. Hence valency of sulfur, K2SO4, here sulfur, K2CrO4 means chromium, K2SeO4 means selenium, all have same valency, 6. Valency of sulfur, chromium and selenium is 6 in all three compounds. Sulfur also 6, chromium also 6, selenium also 6. Now second, see, ZnSO4 7s2O, FeSO4 7s2O, MgSO4 7s2O are isomorphous. These are actually another way also question is asked, examples of isomorphous compound. That way also it is important. Then ZnSO4 7s2O, FeSO4 7s2O, MgSO4 7s2O are isomorphous. Hence valency of Zn, Fe, Mg is equal to 2. Here in these isomorphous, valency of Zn, Fe and magnesium is equal to 2. Third example I am telling you, A.I.M.S, particularly potash A.I.M.S, M2, M means metal, M2SO4, M2-SO4 whole 3, 24S2O is a very good example. M2SO4, M2-SO4 whole 3, 24S2O. Okay. Then here two type of metal is there. One is M2SO4, like Al2SO4. This here two are there. One can you consider as this potash A.I.M. you are telling, and K2SO4, and other is M-SO4 whole 3, 24S2O, means Al2SO4 whole 3, 24S2O. Then here M2 means K2SO4, what you are telling, that M, and M2 dash means aluminum, M dash you can consider as aluminum. Then M2SO4 M2-SO4 whole 3, 24H2O, in which M is monovalent like potassium, and M dash is a trivalent like aluminum, Al plus 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 3 plus. Okay, then here M is monovalent, M dash is trivalent. Then these are isomorphous. Okay, here M and M dash are isomorphous. Knowing valency, if you are knowing the valency, atomic weight is equal to equivalent weight into valency. Means here you can also calculate atomic weight. Then five method I told you. First, by application of relation, atomic weight is equal to equivalent weight into valency. One relation. Other Dulong and Pettis method, that is the atomic weight into a specific heat is equal to 6.4 approx. And third one, that atomic weight of the gaseous element is equal to molecular weight divided by atomicity, where atomicity gamma is equal to Cp upon Cv, and for monoatomic its value is 1.66, for diatomic its value is 1.40, and for triatomic its value is 1.30. And next, volatile chloride method. There already told you that you will get the you can calculate the valency X value. X is equal to 2 into vapor density divided by E plus 35.5. Correct? Then after knowing the X value, then you can calculate X outside in bracket E plus 35.5, that is equal to 2 into vapor density. Then X you will calculate, means valency, and then atomic weight is equal to equivalent weight into valency. And last, now I told you isomorphism method. Okay, you will know the valency, and valency if you are knowing, the atomic weight is equal to equivalent weight into valency. Okay, then this I have told about the methods of determining atomic weight. Now this thing I want to tell you, this volumetric analysis. How will you calculate? How will you do volumetric analysis? Okay, then there are 7 methods. Total 7 methods are there for volumetric analysis. Okay, first, normality of solution is the number of gram equivalent of the solute present in 1 liter of solution. What I am telling you now, 7 I will tell you. You remember always, only then you can solve the numericals. And you know that many numericals are asked on volumetric analysis. Then first I told you, normality of a solution is the number of gram equivalent of the solute present in 1 liter of solution. Second, molarity of a solution. Molarity of a solution is the number of moles of the solute present in 1 liter of solution. Third, number of gram equivalents. Number of gram equivalents is equal to weight of the solute in grams divided by equivalent weight of the solute. Okay, weight of the solute in grams divided by equivalent weight of the solute, that is called number of gram equivalents. Means if you want to know the number of gram equivalent, then given weight you divide by the equivalent weight of the solute, then you will get number of gram equivalents. Next, number of moles. Then number of moles is equal to weight of the substance in gram divided by molecular weight of the substance. Correct? Now next formula you might be knowing also, and now I am telling you, that is the N1 V1 is equal to N2 V2. when a solution is diluted, we can apply normality equation or molarity equation. Then normality equation is N1 V1 is equal to N2 V2. Here N1 V1, that is the before dilution, and N2 V2 after dilution. Correct? When say you have taken in the beginning one solution, suppose it's a normality and volume you are knowing. Now you have put some water. Then new solution, in new solution, volume you can measure easily. But what is the normality? That is the N2 V2. Because both will change, volume will also change because you have mixed water. Then volume will change, normality will also change. Then how will you calculate now new normality? Volume you can measure, but new normality, that is the N2 V2 you are knowing, you can know by measuring with measuring cylinder. Then that relation you can know can calculate by knowing the formula N1 V1 is equal to N2 V2. N1 V1 is before dilution and N2 V2 is after dilution. Or in the case of molarity equation, same way, M1 V1 is equal to M2 V2. Capital M, capital V, M1 V1 is equal to M2 V2. M1 V1 before dilution and M2 V2 after dilution, same way. Okay. Now next sixth relation is when the solution of two substances, an acid and a base, or an oxidizing agent and a reducing substance. It will apply for both. When the solution of two substances, one may be acid, other may be base, or one may be oxidizing and other may be reducing substance. Then suppose they react completely. Okay. When the solution of two substances react completely, we apply normality equation. Here N1 V1 is equal to N2 V2. N1 V1 means solution 1, that is equal to N2 V2 solution 2. Okay, N1 V1 solution 1 is equal to N2 V2 of solution 2. And last relation is in terms of molarity equation. Okay, first why I have discussed, that was also molarity. Okay, but it is little different. M1 V1 is equal to M2 V2, that is also based on molarity. And this is also, I am telling you now last, in terms of molarity equation. Molarity equation, what is that? In terms of molarity equation for the reaction, suppose reaction is N1A plus N2B and it is giving some products. A small n1 number of moles of A plus number of moles of B, it will give some product, that is the N1A plus N2B. N is the small number, a small n. Then in this case, same way, M1 V1 divided by N1 you have to write. M1 V1 divided by N1, that is equal to M2 V2 divided by N2. Why you are divided by N1? Then you want to know per mole. M1 V1 divided by N1. N1 may be 2, 3, 4. Then per mole both should be equal. Then M1 V1 divided by N1, that is equal to M2 V2 divided by N2. Then M1 V1 by N1, that is for A, capital A. Okay, first reactant, and B is for second reactant. B means M1 B1 divided by N1, that is equal to M2 B2 divided by N2. Then first one is for A and second one is for B. Then M1 V1 divided by N1 is equal to M2 B2 divided by N2. Okay. Then I have discussed how to calculate the volumetric analysis. Okay. Now I am stopping only here. Next class again I will continue. Thank you.